Again, welcome to Python programming language. These lectures cover the basic steps to develop a program. Normally, if we are going to develop a program or write a code, we start with analyzing the problem. We need to understand our problem that we want to solve. So we have to analyze it. What is the input? What is the output? And then we design the algorithm that will transform the input to output. So these lectures will show us the basic steps to develop a program that start from analyzing a problem, then designing a solution, then implement the solution by creating a program. So these are the software development process, and also I would say the steps. So first we start with the requirement specification. This is where we do the requirement analysis. Also, we have two types of requirement, the functional requirement and also non-functional requirement. Then we move to the system analysis, then the system design, implementation. This is where we write the code, implement the system. Then we test it. If there's no any errors, then we deploy it. During the process of deployment, we may need a maintenance of the system as time goes on. Now, these steps can go forward and also backward. So for example, during the system design, we saw an error. We can go back to the requirement specification to fix it. Or when we're in implementation, we test the code and there's an error, we can go back to system design phase. So let's go through each phase. The first is the requirement specification. So what requirement specification means? This will be the formal process that seeks to understand the problem and also document in detail what the software system needs to do. This phase involves close interaction with the users and designers. So in the requirement specification phase, this is where we do the requirement analysis, both the functional requirement, which will tell us what the system will do, and non-functional requirement will be the attribute or the quality of the system. The best place we can get this information is from the users, those who are using the system before, maybe if they have used the manual implementation of it, etc. Also the stakeholders of the project. Then next, we're going to move to the system analysis. But again, most of the examples in this course are simple and their requirements are clearly stated. So for example, if we say we are going to write a program to find a sum of numbers from 1 to 10, or to find a factorial of a number, this is not a complex problem. So most likely we are not going to follow these steps. This is more if we have a very large project or more complex. So here we say in the real world, however, problems are not well defined. So you need to study the problem carefully to identify its requirements. Now the next phase, as we said, is system analysis. This is where we seek to analyze the business process in terms of data flow and also to identify the system's inputs and outputs. Then from there, we can move to the system design phase. Now, part of the analysis entails the modeling the system behavior. So the model is intended to capture the essential element of the system and also to define the services to the system. Now, with the system design, this is the process of designing the system components. This is where we need to design the algorithms using any type of tools. For example, pseudocode or data flow diagram or crash diagram. We also have the UML, which is the Unified Modeling Language too, which consists of 14 different diagrams that we can use to design the system. For example, we have a diagram called the use case diagram. This diagram is going to show us how users interact with the system. So for example, if we have a banking system, maybe a customer may interact with a banking system like ATM more different from the employee of the bank. Maybe the employee of the bank may have access to every customer account, may have access to update some information in the ATM, but a customer may not have access to everybody's account, only his account, and he cannot update the whole system. So the use case diagram tells us different type of users and how they are going to interact with the system. From there, we move to the implementation phase. So this phase also involves the use of many levels of abstraction to decompose the program into manageable components. We should also identify the classes and interfaces and also establish relationships among the classes and interfaces. The implementation phase is where, again, we are going to write the code. So as we all know, always we have input, process, and outputs. So again, the process of translating the system design into programs. Separate programs are written for each component and put to work together. Then this phase requires the use of programming language such as Python. The implementation involves coding, testing, and debugging. Now, if the system is very large and complex, maybe we may have different units. We don't decompose the problem. We have smaller units of the problem. When we solve everything finished, then we integrate the whole system together. So the testing, this will ensure that the code meets the requirement specifications, also the standard. It will weed out bugs if there's any errors, etc. This is where we are going to, again, make sure we get rid of them. So an independent team of software engineers not involved in the design and implementation of the projects usually will conduct such testing. Then the deployment makes the project available for use for the organization. Now, during the process of using the system, as time goes on, we may need a maintenance. So the maintenance is concerned with changing and also improving the product. So a software product must continue to perform and also improve in a changing environments. So this will require, again, a periodic upgrade of the product to fix newly discovered bugs and also incorporate the changes. Now, let's see an example here. We have a program to compute a loan payment. So this program will let the user enter the interest rate and also the number of years and the loan payment amount. And then it will compute the monthly payment. And this is the formula that we use to find the monthly payment. That will be the loan amount times the monthly interest rate divided by 1 minus 1 over 1 plus monthly interest rate to the power of number of years times 12, because it's monthly payment, so it's 12 months. So if the loan is 30 years to pay finish, then we are going to have 30 times 12 as the number of payments, monthly payments. So far what we have learned up to chapter 2 of our course textbook, we should be able to solve this problem. First, we need an input. The input, of course, will be the loan amount, which is given, and also the monthly interest rate also is given. And then the number of years we have to pay the loan finish is also given. So that's our input. We can use the input function to get this input, or we can use assignment operator to assign the input to the variables. Then next, we are going to transform this formula into Python syntax. So this will be our process using this formula to find the monthly payment. Then we print out the results. So it's again input, process, and output. Hopefully from next chapter going, we shall learn decision statements whereby we may have a condition. If the conditions is true, we should do something or not. So let's look at this code. It should come right now. Okay. Okay, so here, the first, we need our input. So here we are going to enter our the yearly interest rate. So we use the input function, and the interest rate, we say, for example, it can be 8.25%. If it's 8.25%, then we enter 0.0825. Now, since we know already, when we use the input function to get an input, the data type of that input, whether it's a value or it's a string, still the data type will be a string. Since we are going to do arithmetic operation here, we need to change the data to either int or float. A float means it's a decimal number, int means it's a whole number. So here we get the input from the user for the interest rate, then we convert it to float. The instruction on our screen, this is a console application. We will see enter annual interest rate, example 8.25, then we enter it. Then when we enter it, we are going to find the monthly interest rate, which will be the annual interest rate divided by 1,200. The reason why it's 1,200 because we enter 8.25%. So 8.25% we divide by 100 to change it to a decimal number. Then since this is monthly, we have 12 months in a year. So that's why we divide by 12. So dividing by 1,200 will give us the interest rate for every month in decimal number instead of percentage. So first we have our monthly interest rate. Now the number of years is an input, so the user must enter it. We use the input function again to enter the input. Then we also need the loan amount. It's an input, so user enter the loan amount. So if we know the loan amount and also we know the number of years to enter to pay the loan finish, and also the monthly interest rate which we calculated, it will be the annual interest rate that was given to us divided by 1,200. Then from there we can find that's our inputs. We get our 3 input data. Next we go to the process now where we can find the payment. So to calculate the payment, it will be monthly payment equal to the loan amount times the monthly interest rate divided by 1 minus 1 over 1 plus monthly interest rate to the power x. So again, 2 exponential symbol means 2 asterisks, means exponential. So this means 1 plus monthly interest rate to the power number of years times 12. Now, when we get the answer for the monthly payment, we multiply the monthly payment by the number of years we have to pay in the loan. Then we multiply that also by 12 because the monthly payment, we have 12 months for 1 year. So we know the number of years, we multiply by 12. Then the amount that we pay every month, that will give us the total amount we are going to pay. So we finish with our process now. Our process is to calculate the payment. Next, we do the output. So here we print our payment results. So first, we say the monthly payment is whatever the amount is. Then also the total payment is whatever amount we find. So next also we have a program to compute a distance between 2 points. We know this in college algebra. If I have 2 points, let's say point 1 and point 2, we have S1, Y1, S2, Y2. To find the distance between the 2 points, it will be square root of the difference of X1 and S2 all square plus the difference of Y2 and Y1 all square, and square root of everything. So this means our input should be the coordinates of the 2 points, which will be 4 values because each point have X and a Y. Then we use the formula to do our process, then we print our screen. So again, chapter 2 here is still input, process, and output. So first we enter our first point, the X and Y coordinates using the input function. Then we enter our second point, X and Y coordinate using the input function. Then we use the data for the 2 points coordinates to find the distance, which the distance will be the square root. The square root is the same as exponent of half or 0.5. So this is my square root, exponent 5, everything. So the difference of S2 and S1 to the power 2, which is square, then the difference of Y2 and Y1 all square, then the square root of it. Now, when we get the result, we store it in a distance variable. Then next, we use the print function to print the results. So here we say the distance between the 2 points is whatever the value we have in the distance. So that will be the conclusion of this lecture. So in this lectures, again, we learn the basic concept of writing a programming language. As we said earlier, in this course, most of our programs are well stated and are very small comparing to real world problems. But normally we start with a requirement specification, then we come up with a design, analyze, then before we do the implementation, testing, etc. So we went through the steps of, again, writing a computer program or developing a computer program. Next, we saw two examples of coding that cover our chapter 2. Again, our chapter 2, we are writing Python programs using only input, process, and output. We get input either using assignment operator or the input function. Then we perform arithmetic operations. Then we use the print function to print our results. Now, in our next lectures, we will start to go through the selection statement, which is one of the control structures. So again, wish everybody the best. Thank you.